Right guys, welcome back. In this video we're going to take a look at how we can add a little bit more variety to our fence asset, give it a bit of character, and also it'll be adding more parameters which we can promote to the digital asset level for the level designer to use. Okay, so here we are, we're exactly where we left off. It's kind of the base system is almost in place. There's just a few more things we need to worry about. We need to make sure that it can conform to terrain. We need to take care of all the attributes like UVs and vertex color as well. But before we do that, let's just add some sort of little finishing touches to how we can sort of just randomize this and make it look a little less uniform. Okay, so what I want to do is just manipulate the scale of these fence posts. So I've put the display flag on the copy to points fence posts here. So we want these to be ever so slightly different scales, maybe introduce a little bit of wiggly rotation to them so they're sort of off center a little bit, just to give it a little bit of character in a sort of dead easy way. And also we can promote this up, as I said. So what we want to do, and it again comes back to attributes, it's all about point attributes when working in this way. We can manipulate data on our incoming geometry and apply attributes to that geometry that will then dictate how these things are copied. So we did that with the normal attribute to dictate which way these copies were oriented when they got copied. We can also do that with the scale. Okay, so if I put down an attribute randomize node, so if you just start typing rand, you'll get this attribute randomize node, which is really useful. Okay, and then we plug in our incoming points into that attribute randomize, and I'll just turn on point display. Okay, and you might be able to make it out. It's given each point a random color value. Okay, so that's its default behavior. So it's picking a random color value for every single point, and that's dictated by this attribute name here, CD, which is color, the color attribute in Houdini. Okay. So the attribute we're interested in this case is another attribute that Houdini understands, and that's called p-scale. Okay, so p-scale is just transform scale. Okay, so what we're doing now is we're saying add an attribute called p-scale that will randomly map between the value of 0 and 1. Okay, and then use that to copy onto, use that the p-scale attribute to scale the incoming geometry. So if we plug that into our copy to points, put the display flag on, you'll now see that all of our copies have got random scales between 0 and 1. So with the attribute randomize selected, I'm just going to middle click on this 0 value here, and obviously 0 is a bit harsh, so I'm just going to eyeball it using the viewport just so I can start to get a little bit of variety in there. So something like that, and you can start to see that each one has got ever so slightly different height scaling, just to add that little bit of character. Okay, so when we put the display flag on the end, you can see they've got a little bit of variety in there very, very quickly. So for the cost of one node. Okay, we can do the same thing with rotation. So again, put down another attribute randomize and plug it in directly after the previous, put the display flag on it. And again, it'll be set to CD by default. So another attribute Houdini understands natively, it just knows what it is one called ROT for rotation. All right. So this will apply a random rotation now to all our points. Okay. Now there's a couple of things we need to be aware of with dealing with rotation. It's actually a vector 4, so it's got 4 components. P-scale was dealing with 3 components, X, Y, and Z. Color deals with 3 dimensions or 3 components, R, G, and B. Whereas rotation is a quaternion, which is a vector 4. So we need to set this dimensions to 4 to see any sort of real difference. Okay, so now that we've created this ROT attribute and we've set it to the correct size, if we plug that into our copy to points, you can see now that all those points have been assigned a random rotation. Obviously it's a bit chaotic at the moment, so we can dial that back a bit. Now quaternions, if any of you have done sort of mathematics at sort of A level or something like that, you'll understand that mathematics, that quaternions are a really efficient way of describing rotations, and they have certain benefits over the way that we as humans use rotations. We as humans like 0 to 360 degrees. It makes a lot of sense to us and it just works for us. But computers, it's a bit cumbersome and not particularly accurate and can cause other issues, that system. So computers prefer to use a scheme called quaternions, and that is a vector 4, and the values range between -1 and +1. So they're not really, it's difficult to get your head around. So what we can do is we can tell the randomness, rather than being completely random, we can set the distribution to be a direction or orientation, and then just specify a cone angle here. Okay, so we can specify this range that the randomness will appear in. Okay, so currently it's set to 0, so there's no randomness at all. The direction is incorrect, so I'm just going to swap that over to be on this axis here, and if we very slightly dial up this cone angle here, you can start to see, and again that's something that I would really recommend just being super subtle with, because it will kind of ruin the effect otherwise. You can start to dial in some random rotation for each one of those copies. Okay, and just be wary that, you know, you might start to see bits of geometry poking through, which could sort of mess up your material assignments. But as you can see, it's starting to add a little bit more character to the sort of the very uniform fence asset. So I'm just going to dial that down a bit. It's a bit too much. I don't like the way that this geometry is intersecting through it. So with that, what I think I might do is come back over to our long plank, and in the top view, yeah, so maybe just dial that down to something very subtle. Now you can see it's just starting to get a nice little bit of rotation per point on those assets. Cool. In addition to that, put down another attribute, randomize, and its default behavior is color. So there you can see it really working. It's picking out a random distribution of colors across the entire color palette. So that's not particularly useful. What we could do is we could create our own attribute rather than CD. If we create our own attribute called color ramp and set it down to 1, because we only want a value between 0 and 1. Okay, so this will assign these points a new attribute called color ramp, and then it'll assign a value there between 0 and 1. And then if we can use that attribute with a color node. If we put the display flag on here, and in the color node we can say ramp from attribute, and the attribute we want to ramp is our color ramp that we've just created. And now you can see each one of our copies is randomly selecting between this color range here. So if we set sort of like a light brown, and then maybe, I don't know, a dark brown, again we can really start to build up that randomness in our asset. And again, this can be promoted to vertex color attribute. So in Unreal Engine, this could be used to tint a shader to create, again, more variety and more visual interest. Okay, so in the next video, what we're going to do is we're going to take a look at how we can integrate this system into terrain. Now obviously one of the key things that was identified was that this fence should be able to conform to terrain that was plugged in as an input. So we'll take a look at that in the next video. Thanks.